Hello, world. Good evening, London. Thank you very much for joining this session. This is the last ride of the day. Welcome to Null and Void, everything about nothing in .NET. I will be spending 60 minutes to talk about pretty much nothing. We will talk about the billion-dollar mistake and how we can avoid it with the C#8 feature nullable reference types. We'll also understand the difference to the previously existing nullable value types. We also take a look at other forms of nothing like void and null refs when we talk about by ref instead of by value. We will take a look behind the scenes of how the nullable reference types feature is implemented in C# so that we could use it for our own Roslyn-based or runtime via reflection-based tooling. We also take a look at interop, for example, how the brand new F#9 is now also interoping, allowing nullable reference types as well, and how we can, with nulls, cross the process boundary with JSON. And at the end, we're gonna close things with trying to introduce patterns to avoid null in the very first place. Hello, my name is Stefan. I'm from Austria. I'm a Microsoft MVP, JetBrains community contributor, and a co-organizer of the .NET meetups in Vienna. I am also a co-host of a live stream, and I am a lead software engineer at Tricentis. We built a tool called Tosca, an end-to-end no-code software testing suite. And in the service that we are working on, we extensively use nullable reference types. And the warnings that they produce, actually shifting this to compile time errors so that we don't, or either don't at all or reduce significantly null reference exceptions at runtime. Now I'm wondering, who has observed in their production environments a null reference exception somewhat recently? I see a lot of hands. I can actually lower this hand. However, well, recently I made a bit of an embarrassing mistake with a keynote found exception. So other types of exceptions. My goal is here to make all of you just a little bit more null aware when it comes to the C# language so that we can all drop this number lower or perhaps even reduce it in the future. I assume mostly .NET developers. Who is not developing with .NET? Who is not developing with C#? Somebody F#? Wait, Go. Cool. I do not know how Go is dealing with nullability, but perhaps there are some patterns that apply here as well. Wonderful. This QR code links to my GitHub page where I list all my socials. If there are any questions about nothing that I am not able to answer for you here tonight. So let's start with void. Void is the return type that we use for methods or local functions or delegates to indicate that this doesn't return anything. It can also be used for pointers to an unknown type. Now, did you know that the type void actually exists in the type system? When we take a look at a record, I'm putting this into, sharplab.io, which is compiling the code to IL and then decompiling it back to C#. So we basically obliterate all the syntactic sugar. And when we have a record, it emits a lot of members for this type. For example, it becomes equatable and then also the equality operators. And it also emits a deconstruct method that we can use in order to deconstruct this type into a value tuple via the parentheses syntax. And this deconstruct method is void. If you would like to, via reflection, understand if a specific method returns void, we can do this by, well, getting the method from this record type. And this method, the deconstruct method, the return type of it, we can actually assert that it is type of void. If we can actually F12 or go to definition of void, this is a type that exists in the runtime, system.void. But we actually cannot use it from C#. It's prohibited to use from C#. If we were to try to write system.void, that's illegal. C# compiler says no. We need to use the void keyword. Now let's go into the world of null and nothing. I tend to start my demos recently always with a Visual Basic application because the syntax is very descriptive. It says exactly what it does. I have here a string and I assign nothing to it. I also have a string that contains something. If I try to get the length of the string that has something, in this case we get 13 characters that hello, comma, space, world, exclamation mark has. If we try to dereference the null string, exactly here, and we try to get the length of the string that is referencing null, we get the null reference exception, the $1 billion mistake. Now jumping into C#, let's declare a string. And if we have, say, hello, we can do the same thing, say console.writeLine, and print the length of the string to the terminal. And this should give us 6 characters, if I count it correctly. I'm running the wrong application. And here we go, 6 characters. Now what if this string is null? We have the very same problem. We will run into the null reference exception because we try to dereference an instance of string that is null, and there is no length property to access. So we have the null reference exception. Now, wouldn't it be cool if we could get warnings ahead of time? Nullable reference types is an opt-in feature. So with existing code bases, per default, it's not enabled. You need to opt in to it. If you use from the latest .NET SDKs, the template for libraries, web applications, console applications, you will always get this property per default. If you take a look, there will be nullable enable. And with that flag, we now opt in to the nullable reference types features. And now we can place question marks to indicate nullability to our reference types. I'm here already getting a warning. This warning says converting the null literal or possible null value into non-nullable type. This string here, we have not annotated it with a question mark. So we intended it to be non-nullable. But if we try to assign null to it, we get this warning. And this is what the nullable reference type feature is all about, to annotate your instances with a question mark or not, and to produce warnings if you do not adhere to the nullability contract. So we can now add a question mark here, and now we have the warning down there on when we use it. Oops. We now get the warning, a dereference of a possibly null reference. And this is now indicating that here we may run in a null reference exception. Well, from this code, it's quite obvious because it's just in the next line. I see it at the line above that we say null. But what if this was a parameter to a method and to calling another method, and we have an immense stack trace, difficult to trace where this null is maybe originating from. So when we annotate our fields, our properties, our arguments with nullability correctly, we can then also indicate to the consumer whether null may be passed. But as I mentioned, it's an opt-in feature. If we have, for example, a type, called it the null oblivious type, this type was not built with nullability in mind. So this feature was not enabled. Let's ask the instance this type has. Let's take a quick peek at it. A number and a text. I do have a default constructor which leaves the number to 0. Int is a value type. The default of an int is 0. And the string, the default of every reference type, is null. So again, if we try to dereference text instance, maybe again, let's get the length of it. We will just again run into the null reference exception. But we didn't get any warning. Because in this case, for this type, we actually disabled the feature. You can also enable and disable this feature on a source type, on a source file level. If we switch to the same type, but that to a similar type with the same shape, but that was built with nullability in mind, the null aware type, now we do again get the warning where we potentially dereference something that may be null here, and it's warning us. We still at runtime have the very same behavior. At runtime, nullable reference types doesn't really have an impact. It's all at compile time, so we can shift warnings to compile time before they occur in runtime. Now, because when we take a look at the text, this property is actually annotated with the nullable. If I weren't doing that, if I would say this text, this string is non-nullable, we now get a warning here in the default constructor, the parameterless constructor, because this parameterless constructor lets the backing field of this auto-implemented property to null. So we here now get the warning that the non-nullable property text is uninitialized. And we could fix this by saying text equals to empty string here. Now we don't have any warnings anymore, or we remove this constructor altogether. And now we move the responsibility to not pass in null, to pass something that is non-null, to the caller. So now here I need to invoke the constructor that has 2 parameters. Let's say we call in 100 for the number and text. Well, again, if I pass in null, we do get the nullable warning. If you pass in something non-null, for example, an empty string, the warning disappears. Now we have seen the syntax before nullable reference types, the question mark that we add to types, to type names. We have seen this with value types. For example, I'm taking a look at int here, just string, that's a reference type, so it's a class. An integer, that's a struct, so it's a value type. And we had before nullable value types already, so we could write int question mark and then could assign null to it. But nullable, there is a significant difference between nullable value types and nullable reference types, because a nullable value type is not totally different. If we were to dot into the value, we have 2 properties. We have the value property and the has value property. So where are these coming from? When we jump into the declaration, we actually see we are now in a totally different type. This is no longer an instance of int. It's now an instance of nullable of t, where the t is now the int. So nullable value types, when you add the question mark, we really at runtime, it's a totally different type. Nullable reference types, there is no different type. We'll then later on inspect what's going on under the hood, but it's the very same type. So nullable reference types have no impact at runtime. And in order to use now this nullable value type correctly, I could do my null check, my has value check, and only if it has a value, we then access the value. If we were to access the value without doing the check, in case this integer is null, we don't get a null reference exception, because the thing is with structs, the thing with value types is they always have a value. A value type can never be null. So a nullable value type is a bit of an oxymoron, but syntactically it makes sense because we can assign null to it. But a value type can never be null. So if we have a nullable value type and try to get the value of it without checking if it has a value, we may run into an invalid operation exception. It's not a null reference exception because value types can never be null. Another form of null are refs. per default, when we have a field, a property, a argument to a method, they're usually copied by value. If you have the ref keyword, then we call them by reference. There's also nullability when it comes to reference, those managed references. I have here an example. In my type, I have a value, and I'm getting here a copy of that value. I'm just assigning it to another local variable. So it's a value type, so we copy this value over. And I'm also getting a ref of this value type. Whenever we have a ref, this is now an alias to the original value. So in this case, value ref is an alias to value. Now, when we modify the copy, the original value remains unchanged. When we modify the ref, so the alias, the original value is changing respectively, because it's a reference to this value, to this memory location directly. It's not a copy. When we deal with refs, we can also have null refs. In this case, when we want to check if a ref is null, we need to use the method unsafe is null ref. Then pass this ref to this method, and in this case we get false because this is not a null ref. In order to produce a null ref, we say null ref unsafe.nullref. You may see this example, having an example of a dictionary. We're initializing it with a key and a value. And if I have the use case of trying to get a value without trying to add a value if it doesn't exist yet, so that we don't override existing values, we would need to first check, does this dictionary contain a key? And if it does not, then add the value. And in some cases, a dictionary may contain bigger structs. Well, I just have an integer here. An integer is very small. It is copied by value, so the copying is super fast. In very rare cases, you may have bigger structs, and if we copy big structs around, they may show up in performance diagnostics. So in order to avoid that, we could avoid getting a copy of this value, but actually getting a ref to this value. And the ref on 64-bit systems, that's a 64-bit integer, so you copy it super quickly. And for example, if we now, there is a method in collections Marshall where we can get a ref to that value or a null ref if it doesn't exist. So I'm asking here for the other key. This other key doesn't exist, so we get a null ref. And in this case now, null ref returns true. You may need this in some cases or may see this in some cases. In the BCL, this is used quite a bit, because if we, for example, check into dictionary.tryGetValue and jump into the code, this is what they use internally. They have some internal find value method that returns this value by ref and then does a null ref on it. If it is a null ref, that means the value has not been found. If it is not a null ref, the value was found. So much for the different manifestations of null and nothingness. When we design our types, we need to be now mindful about placing question marks or not. Doesn't find. I believe I forgot to include a. No, there it is, excuse me. So, for example, I have here this base type, an abstract class, which has a get method that may return null. Now, other types may override this derived class, and maybe this derived class will never return null. So we can actually override this get, but remove the nullable annotation. So from a contractual level, in this case, we can actually return something that is not null. But it doesn't work the other way around. If we have on the base class, if we say on the base class level, this is not null, but on the derived type, we say this may be null, we now get a warning here because we are getting less strict. Because if we were to instantiate a type of derived and assign this to an instance of type base, at compile time, it says, well, get returns a non-nullable string, but at runtime, it's actually derived type, and it may return null. So we wouldn't produce a warning, but still get potential null reference exceptions, and therefore, we get here yet another nullable reference exception. So be mindful when you expect something to not accept null, then avoid the question mark. If it may be null and you have null checks in your method, then you can do a string question mark. Now is the compiler figuring out where to place the warnings. And this is happening via the static flow analysis. Again, I have here a small example with a type that has a property, a non-nullable property. We have one constructor that sets that property. So this one does not produce a constructor, an error warning. If I were to add a question mark here, I would be assigning a non-nullable string to a nullable string to a non-nullable string. Therefore, we get the warning here. But this default constructor does not set text, so just leave it uninitialized, leaves it to null, and therefore we get the warning in this constructor. And with this information now, the compiler is enhancing these types and information with a bunch of attributes. If we were to put this code again into SharpLab, we see that if I search for question mark in the decompiled code, there is no question mark. So this question mark is just a C# syntactic sugar that doesn't really exist. So this feature is working by adding attributes to your code. So when we have nullability, we actually add those nullable contexts and nullable attributes to all of our types. If I were to disable the feature, nullable disable, those attributes are now gone. Let's enable it again, and here they are. So the compiler is placing these attributes and informing then the consumer whether something may be null or is not null. There is a bunch of magic numbers here. A 0 means oblivious. That means if we do not know, so this code was not compiled with nullability in mind. We have 1, that means not annotated. Oh, sorry, that means annotated. Annotated. Not annotated, so. 1 means not annotated, so that's not nullable. 2 means annotated. So this is nullable, so there is a question mark on that. And in this case, we have a nullable context of 1, which now applies to the entire type, and therefore this string is non-nullable. If we were to place a question mark here on the second constructor, we get here now, because this nullable context up there applies to the entire type, but there is now another nullable context that is close, that only applies to this constructor, therefore is closer to the thing that this attribute is added to, and therefore wins. And we have the 2 here, and the 2 means it is annotated, which indicates this question mark. So we have our producing types that now have those attributes, and the consumer, when we, for example, dot into something or try to assign something that may or may not be null, we then get these warnings due to these attributes. And the C# compiler is consuming these attributes, and the F# compiler now since F#9 as well. Now we talked about defaults. The default of a reference type is null. The default of a value type is 0 initializing all its fields. I'm having here a my class. This my class has a number and a string text. And we ensure that in this constructor, we also set the reference type to something, so we do not have any warnings. So we fulfill here the nullable contract. It's non-nullable. If we do the default of this instance now, the default of a reference type, since my class is a class, is basically the equivalent to null. So this is always null, and therefore this instance is null. The thing about structs, I have here now the struct. It's the same type, the only difference is this is now a struct. It also has a non-nullable field, or a non-nullable reference field and a non-nullable value field. But if we were to default initialize this, struct can never be null, so all its fields are 0 initialized, which in the case of the reference type here will be null. Now we don't get any nullable warning, but still we may run here in a null reference exception. If we try to dereference this text is indeed null at runtime. The compiler does not emit any nullable warnings for structs, because for a struct you can always call default. You can always 0 initialize all of its fields. So even if I have the parameterless constructor here, this parameterless constructor is not called if we do default. That's different with reference types, because a reference type we can just assign null to it. It may be null, the reference, but the value type always has a value. So with this default, it can be that reference types may be null. But the compiler doesn't emit warnings here because it would be very noisy and there's nothing really you can do about it, because a value type always has this default 0 initializing way of constructing it. Another thing is about arrays. When we have arrays, now initializing here an array with the length of 2, and I'm only setting the 0 index element to 1. Now, the 0 index element will indeed be 1, but the 1 index element will be null. But we don't get a warning here again. If I were to say element.length here, trying to dereference it, well, this assertion doesn't make sense. Let's say we were to check if this element is 1. We do not get a nullable warning here, but we would run here in a null reference exception, because we have not initialized the element at index 1. This is another bit of a caveat when it comes to arrays. The compiler doesn't produce warnings here either, if you produce the arrays yourself. If we were to use, for example, collection initializers, 1 and maybe null, we now do indeed get the warning. So the compiler can check that here. But those are those two caveats where we may not get nullable warnings when it comes to reference fields in structs and when it comes to arrays that we create ourselves with a specific length. Of these we need to be mindful of. So now when we have this nullable warning, what can we do about it? Well, we can do good old null checks. So if we have, just having now an instance here of a record, we check if this record equals null, and then we have the if and the else in the case if it's null or not. A very common null check is, well, doing equals null. I'm casting this one here to object because there's a fine difference between equality operators if your types overload the equality operator or not. Because again, this record type is a record, and the record overloads all the equality operators. If we jump back to just an example of the record type, there it is. The record type actually overloads this equality. So if we call equals null of an instance that overloads the operator, then we do call indeed in this operator. If we first upcast this instance to object, now we are an object, and this is now a raw null check. So if we take a look at the IL code, this is as much as a null check as it can be. But this is a little bit tedious. So in order to get a raw null check, these days we just write our code like so. With pattern matching, we say is null, or the opposite is not null. And the compiler can now figure out, for example, if we were to assign this to null and say, please be null. And let's dereference this record in both cases. In the if check, we say record is not null. So the compiler now knows that in this block, record is not null. So it's safe to dereference. But everywhere else, this record may be null. So we get the warning down here. This could end up in a null reference exception. There's many more operators when it comes to null. Let's say we do again a string nullable text set to null. If we want to safely dereference it, we could say text question mark dot length in this case. Now this is an expression that will produce null in the case of this text being null. And we could combine this with the null coalescing operator and maybe then say something like empty here. Sorry, that's a length, that's an integer, let's say -1. So in this case, if the text is not null, we get its length. If the text is null, we get -1. In array, when we have an array, we can also use a question mark indexer. Again, asking for the length here, where we will only now index into this array if the array is not null. If the array is null, this expression produces null. There's also I need to look up the name, the coalescing assignment operator. So we can write array equals question mark, and let's then say array dot empty. Where this expression now assigns the empty array in case array is null. So in this case, after both expressions, array would be empty. But if this array is not empty, is not null, let's say it's empty, well, let's fill it with 3 elements. Now this expression would not be executed because it's basically an if check. If the array is null, then assign the right-hand side to it. If it's not, do nothing. And in C#14, we will get a new operator when it comes to nullability. Going here now to the Roslyn repository, where we can check out the features that are currently being worked on for C#14. So this may change, but we will also get this nullable assignment where we could do the question mark dot operator and then on the right-hand side assign something to this. With C#13, this will produce a compiler error. This may work if it's released in C#14. Another thing about arrays, when it comes to arrays, we can have 2 question marks actually. We can have a question mark on the element type, and we can have question marks on the array itself. So this last question mark says, may the array be null. And the inner question mark after the element type says, elements of this array may be null. So in this case, we also could have a null as an element in this array. If we were to remove the question mark from the element type, now this one again is flagged as a warning because each element should not be null. The array itself, however, with this question mark, may be null. So yeah, the warning we get here is because we're not using this array. One more thing when it comes to configuring nullability. There is actually two different nullable contexts. There's the nullable annotation context that is producing those attributes that we saw, and the nullable warning context, which is warning us when we try to dereference something which is annotated with being null or nullable. And we can use this individually, we can use them individually from each other. When we jump back to the C# project, we enabled, when we say nullable enable, we enable both nullable annotations and nullable warnings on the entire project level. We could, for example, say only enable annotations on this level. So we can actually write string question mark, but there would be no warnings when it comes to nullability. We could say only enable the warnings. In this case, we cannot use string question mark in this assembly, but we would get nullable warnings from types that we use that have been annotated with it, from third-party libraries or from the BCL, for example. And we can disable the feature altogether, which is the default. Now, when we enable this on a project level, or whatever the default on a project level is, we can override this default on a source file level. So in this case, well, I have a constructor. If I make this, I have here a required text, which is non-nullable. But I have a constructor that doesn't set this non-nullable string. So we would get a warning here, but we can, via nullable disable warnings, from this point on and below, disable nullable warnings, which means the nullable annotation context is still active. We still can use question marks here. For example, string text equals to null. That's still allowed. If I were also to enable the nullable annotations, so nullable disable annotations, we now get a warning here in this question mark, because it says the annotations for nullable reference types are not enabled. A shorthand for disabling both warnings and annotations is just saying nullable disable, which enables both contexts. So we can enable and disable them individually on the file by file level, which can come in handy when you adopt this feature in your existing code bases. When we do a restore, we get whatever was set on a project level. So in this case, when we restore the warnings, we get the default that is on the project level, and on the project level, we enabled both. So the nullable annotations, the nullable warnings in this case, are enabled again for the rest of this file until this next preprocessor directive occurs. Now, tools like System.text.json is already making use of this feature heavily. Let's take a look at a web app example. So I'm starting up an ASP.NET Core web app, and the system cannot find the file specified. Now that's embarrassing. Oops. Let me just quickly revert some changes because I broke something down there. Is it just that? And let's build again. what is now hopefully starting, is a small ASP.NET Core minimal API web application. I'm afraid can't load some assembly. Please apologize that. But this would show, yeah, a little ASP.NET Core web application. And for the System text JSON deserializer, we can enable options such as respect nullable annotations, which now enables the serializer and deserializer, in particular the deserializer, to respect those annotations. And if you try to assign something null that was not annotated as null, then we would get the deserializer would throw a JSON exception. So with this in place, taking a look at the DTO, we have the title is not annotated as nullable. So this is non-nullable, but the message is. So if we were now to invoke the post API to create a new to-do item, this request would succeed. Title is not annotated as nullable, message is, so this null is fine. I could add a message because it's just adding, it's annotated as non-nullable, but we can add something that is not null. But if I were to set null for this message or leave it out entirely, so that's on a JSON level, it's undefined, this would now on a deserializer level throw an exception, and this request would fail with, I think, a bad request exception. So when we cross the process boundary, we don't have the nullable warnings. They are only in the assembly in the metadata of the .NET assembly. When we cross the boundaries and we have annotations, for example, exposed via OpenAPI and such, we need then tools that respect these annotations. And in most cases, the defaults are not strict, but we can opt in to stricter behavior, such as respecting these nullable annotations and therefore failing serialization or deserialization if this nullable contract is violated. In some cases, you know better than the compiler does, and you want to suppress these nullable warnings. We can do this with the opposite of the question mark, with the exclamation point. So whenever we do an exclamation point, we can suppress nullable warnings. In this example, I have a type that has a private constructor and a non-nullable string. If I were to remove this, we get, of course, the warning at the constructor because this constructor does not initialize the non-nullable string. So we can say here, I want to suppress this warning. That's called the null forgiving operator. So we don't get a warning here now, or no nullable warning. Because, the constructor is private, nobody could call it. We have in this example here a static create method, a factory method that does create this instance and then always sets this text. It's a bit of a contrived example, but the compiler cannot figure out here with the static flow analysis that this constructor can practically not called by somebody else, and the only path that can be called is here, and it ensures that this text, this non-nullable string, will not be null. So we can suppress this warning here because in this case we know better than the static flow analysis of the compiler. Another very common example is, for example, in link. We have here an array that accepts both, that accepts a nullable array, where its elements may be null. And this method, should the entire array be null, return an empty array. And if the array is non-null, then filter all null elements out of this array and return a new array that doesn't have these null elements. So I'm just using a link filter here where we say where these elements are not null. But in this case, if I remove the null forgiving operator again, we get a nullable warning. Because this array here, these elements of this array are annotated as nullable, therefore the where also produces nullable strings. But in our return, we say it's non-nullable. So we transform from non-nullable string elements to nullable string array elements. Well, I could make them nullable, so the warning disappears, but I want to annotate it correctly. And in this case, again, I know better than the compiler because the compiler can't understand what this where filter is doing. And in this case, functionally, is removing all of the elements that are null and then creating a new array from it. So again, in this case, we know, we also have unit tests that confirm this behavior. We can say, please suppress this warning. This is not null. In cases when we deal with generated code, who has already seen a source generator in action or took a look at source code that was auto-generated by a tool? See 20, 30%. A lot of the auto-generated code needs to opt in to this nullable behavior because by default, nullable reference types are disabled in auto-generated code, irregardless of what we have set on the project level. So what you see in a lot of projects is that we do enable the nullable feature, and then in this case need to correctly fix the problem and return something that is not null. An auto-generated file is a file that has this auto-generated comment on top or ends in a .g.cs or .generated.cs. There is more rules what the compiler is registering as a generated file, but those are the most common versions of it. So this is a very common pattern. You see the auto-generated comment and then immediately enable nullable to opt in to this feature. Now we discussed the significant difference between nullable reference types and nullable value types before. One is only compiler annotations. The other one is a totally different type at runtime. So when it comes to generic, there are some caveats to this. So let's go into a generic example. Well, when we have an unconstrained generic class, or would also be the same for a method, where we just have a generic of t, there is no generic constraint here. So this one is unconstrained. Therefore, we could use pretty much anything. We can have a nullable value type, a non-nullable value type. We can have a non-nullable reference type and a nullable reference type. Everything goes. If we want to constrain this to be not null, we can use the new, this is new also in C#8, the not null constraint. So in this case, now only non-nullable value types and non-nullable reference types are allowed. So this one produces no warning. If we were to use a non-nullable value type, we now get a warning here because we violate this constraint. Same with a nullable string. We may see this constraint on the dictionary. When we jump into the implementation of dictionary and browse to the right side, we see that where t key is not null. So we cannot add a null key to a dictionary. This would throw an exception. Because the dictionary is hash-based, we need something to create this hash code off, and null doesn't really have a hash code. So if I were to try a dictionary that has, let's say, string question mark as a key, now we get the warning here, and we are violating the nullable contract. We can also constrain t's to only be reference types with the where t is class. This has already existed before, but when we enable nullable reference types, this now means non-nullable classes. And if we want to have nullable classes, we can also add a class question mark to that. So the non-null class, well, it of course doesn't allow ints because that's not a reference type, but it also doesn't allow, well, it allows, but it's a warning. It produces a warning if we have a nullable reference type. But for the generic that may be null, where we say class question mark, we can have a nullable reference type without a warning. There is also the struct constraint. Now this can only be value types, but there is no struct question mark constraints. Because of the difference the difference between a nullable value type and a regular value type is significant. There's a totally different type in place. One has this has value pair, the other one does not because it just has a value. And so this is the difference between those two nullable reference and value types now don't allow this scenario. And in some cases, we need to help the compiler to figure out more about the nullability. And for these, we have a bunch of nullable attributes. They have been added in, I think, in Net Standard 2.1 and in .NET Core 3.0, I believe, or 1. We have additional attributes that we can use to annotate to enhance our nullable annotations. For example, if we have a property that returns a string, now the backing field is also non-nullable. But if I want to allow null to be set, but ensure that the getter does not return null, we could now put the allow null attribute on top of it. And this now enables us to assign null to it. Without this attribute, we would here try to assign null to something that is not annotated with a question mark, therefore we get the warning. But we have ensured in the setter that should a null come in, we actually set string empty. So the backing field text will never be null, and therefore we can basically annotate this property with the allow null attribute. This also works the other way around with the disallow null, where we have a nullable reference type as a return type and as a backing field type, but we do not allow null to be set. So this is now the other way. We get the warning here because this will actually now throw this exception. There's a bunch of more attributes. I've listed them. This repository is on GitHub, and I've listed all of them also with a page where this all is documented. But a very common annotation I would like to briefly cover, which is on a dictionary. On a dictionary, or pretty much a lot of these try-get methods that return a Boolean, and in case the Boolean returns true, we then have this out value set. We have the maybe null when attribute. And with this attribute, we can now help the compiler, although we have here the out string question mark because it may be null. In the case of this try get returns true, in this block, we don't get the warning due to this attribute. In the else block, of course, well, it's still maybe null because of the annotation here. And there's two handfuls of these attributes with which you can further enhance your annotations. Now, these annotations can be used also for your own tools at runtime, because those attributes that are placed on all of these members, they're just attributes. You could read them as they are. There is a type in the BCL, I think it was added in .NET 5, the nullability info context. And with this nullability info context, we can ask reflection-based questions. For example, we could create the so-called nullability info of this parameter info type. So that's a parameter to a method that comes in, and then query its nullable state. And we saw with these attributes, we could disjoint the nullability when it comes to the get and the set. And this shows in the read and the write state. So they could have different forms of nullability. And with this information, we could have an application that this one, yes, with a class. we see that this class has various combinations of nullability passed in. And if we pass this class now to this code that is, oops, sorry, wrong application. That is now utilizing this nullability info context and reading at runtime these attributes, we can now get basically a visual representation of this code. Such as we see that this first string, it's a nullable string, read at runtime. We can also via Roslyn read this information at compile time. So we can write our own analyzers that help us with nullable annotations. For example, in one project that I was working on, we were using data contracts heavily, and we wanted to connect them with nullable annotations. So if this data member is required, we introduced an analyzer that when we have a nullable reference type or a nullable type with a data member that is required, we now produce a warning. Also the other way around, if this was not required, this should be nullable. If it was not nullable, again, it's a little bit ambiguous. It's not required, but non-nullable. Something's wrong, so flag a warning. And that's the analyzer. With an analyzer, you can also have a fixer, where you then have an Alt-Enter or Control-Dot experience in your IDE. In this case, change nullable, which is now changing the source code and properly adapting it. So if is required is true, but the string is nullable, we could invoke this fixer, and it now changes it to match this annotation up here. And there's a whole set of Roslyn compiler plugins that you can write yourself. Now for the last point, I would like to talk about how to adopt nullable reference types for existing projects. If you have big code bases that existed before nullable reference types and you haven't opted into this feature, it's pretty much not possible to like in one big commit or in one day, fix all of the nullable warnings and properly annotate all of the types. So one strategy is to do this over multiple commits, over multiple days, weeks, perhaps even years. You could enable this feature on the project level, but then still disable this feature nullable disable this feature on all of your types. So this doesn't change really any behavior, but I'm wondering, it's not a way, oh, yes, I should also opt into C#8 or higher. And then whenever you touch a file that has this nullability disabled, you could then remove one of these preprocessor directives, go through the type, fix all the warnings. In this case, we return null, so we should also add a question mark here, and do this on a file-by-file level until you have your entire source code annotated, and then you're done. This is, I think, what the .NET team did to step-by-step null enable their types. The other way is you do the opposite. You basically go to each and every file. So you leave your code unchanged, but when you touch a file, you can then go to nullable enable, and again, enable them on a file-by-file basis until you have nullable annotated and fixed all the nullable warnings in your entire project. If we are in a net standards project, the net standard project doesn't have this nullable attribute types available just yet. So how can we get them? There's multiple ways. You could add them yourself, but that's a little bit tedious. There is one project that I like, is PolySharp, which is basically polyfilling for lower target frameworks. And it now has a source generator that produces these attributes for us. So if we go into the Net Standard 2.0 output, there is a bunch of generators, and one of these generators is, for example, this allow this allow null attribute that is emitted by the compiler. You can also use polyfill for other features, like if you are on a lower target framework that doesn't types like range, index, and other types yet, this polyfill package can help to enhance your net standard 2.0 libraries with newer, to enable newer C# features. And the very last treat will be, how can we avoid null in the very first place? We could have a so-called null object pattern applied. A null object the null logger, there we go. A null object is a type that implements a specific interface, implements it all, doesn't throw any exception, doesn't have null anywhere, but does nothing, or something as close to nothing. So for example, when we have a logger, that's from Microsoft extensions.logging, and we want to implement a null logger. Now we implement this interface. We have the begin scope method, which should return something. It shouldn't return null. The is enabled returns false, because when a logger isn't enabled, that's close to nothing. And the log method, since it's a void method, just doesn't do anything. The begin scope method, however, needs to return something. So again, we can create now a disposable null object, which is the same thing. It implements the iDisposable interface, but its dispose does nothing. Now, since null object types don't really have any state, we can use the what are they called? Singletons, thank you very much. We can apply the singleton pattern because they don't have any state, and we can avoid allocating a lot of objects that don't have any state, so we can reuse the same instance. Thanks for helping me out. And in some projects, you can also see something like optional types. This, for example, something that I believe F# is using. Well, not really to avoid null, because F# avoids null on a language level itself, but a similar pattern. And we could, for example, have optional types that also work with reference types. And we have, again, something like a has value and a value property to check. But yeah, what would happen if we access the value without checking for has value? It's still not really 100% safe from a compile level. To make it more safe on a compile level, we could change these nullable warnings that we took a look at to be actually errors. So what we can do is say warnings as errors, and we can pass the nullable here, doing this for the release build. So if I were to build this project in release build, we would get a bunch of errors. It wouldn't compile. This, for example, this is something that we have in our project. So we don't even allow any nullable warning violations into our source code. And this is how we achieved to avoid null in the first place. And should you, since I mentioned it, F#, should you open a new F# project in .NET 9 and F# 9, F# now also allows null annotations. You will see them something like this. This is to not only allow nicer interop with C#, because in C# we have null all over the place. F# doesn't have null, but when it calls C# methods, then there may be null. And this is now how they could annotate F# code to also be null aware. And the same pattern, we need to enable this feature via the nullable enable property. But not only for interop with F# code, with C# code, this is also valid when, for example, you have F# code that goes via JSON beyond the process boundary. And yeah, to have nullable annotations, because via JSON we can actually get two levels of null, and undefined. I'm listing here the repository with all of the examples, should you be interested in it. I also have a bit of an interactive demo where you could click through the thing and maybe assign null here, run the code, and then get reference exceptions if you would like to go through this presentation at your own pace. And with that, there's nothing else left to say then. Thank you very much for joining this session. Do enjoy tomorrow's last day at the conference. And I think now is party time, isn't it?